Assalamu alaikum, dear grade 9 students. As you know, geometry is a chain of rules and ideas that you have to keep in mind all the time. That's why in these videos, I'm going to remind you of all plane geometry ideas and rules you need to know. And here we go and start with the kinds of triangles. The first kind of triangle is just the scalene triangle that has no properties. It's just any triangle that has 3 sides and 3 vertices. A, B, C is a scalene triangle. The vertices are A, B, and C, and the sides are AB, AC, and BC. Nothing special about it. There is also the isosceles triangle. It's a triangle that has 2 equal sides, as you see here in the figure, and it has 2 equal base angles. So as you see here, ABC is an isosceles triangle. It has 2 equal sides. AB and AC are called also equal legs. The angle here is called the vertex of this isosceles triangle, and the equal base angles are angle ABC and angle ACB. Also, there's the equilateral triangle that has 3 equal sides and 3 equal angles as well, of measurement 60 degrees for each one. Where does the 60 degrees come from? Let's see. ABC is an equilateral triangle, and as you know, the sum of angles in a triangle is 180. So definitely, because the 3 angles are equal, then each one of them is equal to 180 divided by 3, and here where 60 comes from, by dividing 180 by 3. And finally, there is the right triangle. That's a triangle that has just one right angle, and the facing side to the right angle is called the hypotenuse. So as you see here, there is a right angle, A, and the side facing it is called the hypotenuse. Let's continue to see what we have to know more about plane geometry. We have to know about the types or the kinds of a right triangle, and let's get started. First of all, we have to know about the right isosceles triangle. What's a right isosceles triangle? It's a right triangle that has 2 equal legs and 2 equal base angles as well, of each of measurement 45 degrees. So here, as you see, is a right isosceles triangle. Here are the equal legs. Here is the right angle. Here is the hypotenuse. Now, how to maintain that the base angle is equal to 45? By doing that operation. To find the base angles, I just subtract 180. I write 180 minus 90, and the answer is going to be divided by 2, because the base angles are equal, and thus we get 45 degrees for each of them. Now let's continue to see what we have more. We have the semi-equilateral triangle. What do we mean by the semi-equilateral triangle? If we have an equilateral triangle whose angles are 60, 60, and 60. The semi-equilateral means a half equilateral triangle. So if I'm going to divide this triangle by half, here I'm going to get a right angle, because in the equilateral triangle, the median, because I'm dividing it in half, this is a median, this is the midpoint. The median is going to be a bisector for the angle, for the vertex, and it's also a perpendicular bisector and a height. That's a property of the equilateral triangle. Thus, here we get 30 degrees, here we have 90 degrees, and here we still have 60 degrees. So the equilateral triangle, the shaded one, the semi-equilateral triangle, the shaded one, is a right triangle whose other angles are 30 and 60. So what's the semi-equilateral triangle again? It is a right triangle whose angles measure 30, 60, and 90. Let's continue to see what do we have also in the right triangle. Properties of the right triangle. Let's take a look at this figure. In this figure, we see a square of side B, a red square of side A, and a blue square of side C. Surely C is greater than A and B. It is so clear that C is greater than A and B. In the middle, there is a yellow right triangle of sides B, A, and of hypotenuse C. Using an experiment, some experiments were made on this shape, and the squares were filled with water. You can see it on YouTube or in Google. The squares here were filled with water, and when they pour the water, the amount of water here and here filled all of this square. And by this, we can prove that b squared plus a squared, which means the area of this square, that's b squared. You know that the area of the square is the side squared, and the area of that square, when added together, we will get the area of that square. And thus, we can conclude that a squared plus b squared equals c squared. And that's Pythagoras theorem as well. If you need to know more and more about Pythagoras, the mathematician, you can search Google and find more information about Pythagoras. So, what does Pythagoras theorem say? In any right triangle, it's only applied in a right triangle. It says that the hypotenuse squared, here is the hypotenuse, BC squared, which means the hypotenuse squared, is equal to AB squared plus AC squared. This side squared plus this side squared. So the sum of the squares of the sides. So the hypotenuse squared is equal to the sum of the squares of the sides, the other sides than the hypotenuse. And here are training exercises to understand Pythagoras theorem. Exercise 1. Using this figure here, if AB is equal to 4, here is AB, and AC is equal to 3, here is AC, we need to calculate BC, which is the hypotenuse. Using Pythagoras, BC squared equals AB squared plus AC squared. So just evaluating, BC squared equals 4 squared plus 3 squared, then 16 plus 9, which is 25. And thus, BC squared equals 25. Then what about BC? We just make radical for 25, and the answer is 5. The measurement is always positive, so we don't have to put plus or minus. BC is just the radical of 25 and not the square root of 25. Exercise 2. If BC equals 10 and AB equals 8, so BC is the hypotenuse and it's given here, and the other side AB is given. We need to find AC, so the missing here is not the hypotenuse, it's a side, even though we just write the property as it is. We write BC squared, even though BC is given, we just write the property as it is. BC squared equals AB squared plus AC squared. Now evaluating, BC is 10, then BC squared is 10 squared equals 8 squared plus AC squared. Then taking 8 squared to that side, AC squared is 100 minus 64. Thus AC squared is 36, and thus AC equals radical 36, which is 6. Finally, exercise 3. If BC equals 2 radical 3, this is BC again, the hypotenuse, and AC here is equal to 2, I need to find AB. Again, the hypotenuse is given, but the property stays the same. BC squared equals AB squared plus AC squared again. Now, I have to evaluate. 2 radical 3 squared equals AB squared plus 2 squared. 2 radical 3 squared is 12. Taking 2 squared to that side, AB squared equals 8. So AB is equal to radical 8, which is 2 radical 2. So here are 3 exercises. Here we have to calculate the hypotenuse, In these two exercises, we have the hypotenuse, we just need to calculate one of the other sides. The property is still the same. All what we have to change is the values that we are going to substitute. Now, converse of Pythagoras theorem. What's converse of Pythagoras theorem? What do you think of? Pythagoras theorem says that if I have a right triangle, then the hypotenuse squared is equal to the sum of the squares of the other sides. So what about converse of Pythagoras theorem? It must be, if I have this property, if I have that b squared equals ab squared and ac squared plus ac squared, I can deduce that ABC is right at A and its hypotenuse is BC. Here is a training exercise. Suppose that BC is given radical 18 and we don't have here a right triangle. We don't have this symbol. So suppose that BC equals radical 18, AC equals radical 2, this is AC and this is AB. We need to prove that ABC is a right triangle. So we can deduce that converse of Pythagoras theorem is needed and used to prove that a triangle is right. So how do we apply it? We just have to check if BC squared equals to AB squared plus AC squared. We just have to evaluate. Is radical 18 squared equals to radical 2 squared plus 4 squared? Is that true? Let's see. Radical 18 squared is 18. Radical 2 squared is 2 and 4 squared is 16. 18 equals 2 plus 16, which is 18. True. Then we deduce that this triangle is right at A and the hypotenuse is the longest side, as you see here, which is BC. And thus BC is a right triangle and the reason is written as converse of Pythagoras. Hope you enjoyed Pythagoras theorem and we'll meet inshallah in more videos explaining more geometric ideas.